Okay, right. Now this is actually very helpful in understanding the functions, because functions, when you are writing a function, most of the functions are given with the conditions to understand the conditions better. Because if you don't understand the conditions better, you may choose a wrong value, you may choose the wrong expression. So therefore, to avoid that we must have the idea about the intervals. So today we are going to discuss about the intervals. It's actually, graphical way it will be very easy, but if you write it in the form, you will, no, actually not confusion, but there are some people who feel it is confusion. It's not confusion. I will try to give a visualized way of understanding the intervals. Okay, see, generally we have the brackets like this, and we have the brackets like this, and sometimes we have the brackets like this, and we have the brackets even like this, right? I think almost everything is covered. That's a various way of, these are the different ways of brackets we are having it, and in that, in between we have the values. Okay, so this is what we are going to understand here. These brackets are called open intervals. This parenthesis, these brackets are called open intervals. And these brackets are called, these square brackets are called closed intervals. Closed intervals. Okay, open intervals and closed. This is open and closed. This is closed and open. So what is this all? Okay, so we'll try to understand this. See, the closed brackets are just like gate, and open brackets are just like this. Okay, see, to understand this, let us take two numbers a and b. So a and b are two real numbers. A comma b belongs to r. Okay, I am taking a and b in such a way that a is either less than b, or a can be equal to b. So can I write this combined two statements into a one statement, combined statement? Can I write this as a is less than or equals to b? So this is how we are taking the a and b. So now we'll see. First we'll discuss about the closed brackets. Okay, see, what do you mean by this? What is this? It's a closed bracket. So how to understand this? Let us assume this is a number line, and let us assume this is a number line, and let's take this value is a and this value is b. We already said a is smaller. Okay, let's take this x-axis. A can be any real number. Okay, a and b. So a is smaller, b is larger. Sometimes it can be equal also. Okay, right. Now, what we are doing is, we are taking this one, this uh, closed intervals. So let us assume, now did I include a? Yes, I included a. Okay, because it's square, it's including. Now this side also I included b. So a and b are included. Okay, see, what actually talking about is, we are talking about the space in between a and b. Space in between a and b, including a, including b, in closed interval. So for example, we don't know the value, we don't know, for example, I am taking some points over here, we don't know the values of it, there are some random values. So in mathematics, for example, if you don't know any value, what we can say? We can say that is a x. Let us assume, can I keep x value here? Yes, because a is included, so x can be what? X can be a. Can I keep x value b? Yes. In closed intervals, we can a and b both are included. Okay, they are included. So therefore, x can be a and x can be b. Now, for example, if I take x value here, is it greater than a? Is it greater than a? For example, I am taking the value here. Definitely, see, for this value, this point is right side to a, therefore that value is a, greater than a, right? So can I say x is greater to a? Next, for example, can I say x point here also? Yes. Okay, you can take a random point, x can be here also. Now can I say this value is greater than b? No, it cannot be greater than b, cannot be greater than b. X can be b, but x cannot be greater than b. So what is that? X is less than b. X is less than b. So how can I write these statements combining together? Can I write x is greater than or equal to a? Can I write this statement as x is less than or equal to b? Okay, I am just combining these two statements. Okay, this is called if two mathematical statements are writing, which are called combined mathematical statements, a compound statement. Yeah, this is a compound statement, this is also a compound statement. X is greater than or equal to a, x is greater than or equals to, x is less than or equals to b. I cannot take greater than b because greater than means x is crossing the limit. Okay, I am taking the values only in between a and b. So x is less than or equals to b. X is, but can I take x value less than a? Can I take x value less than a? You cannot take x less than a. So x must be either a or greater than a. X must be either b or less than b. Okay, then only it, I mean, it shows this space including this a and b. Now I wanted to combine these two statements again. This is one statement, this is one statement. Now what is the common thing here? X is a common thing, so it is better to write x in the middle. So if I wanted to write the x in the middle, see, for example, is it possible to write these two statements together in this way, in this manner? If I write like this, x is greater than or equal to a, x less than or equal to b, is it not confusing a and x? What do you mean by this x? It is not correct, right? So therefore, x is a common thing. So x you can see here, x you can see here. Okay. So what I wanted to do is, can I write this as, okay, to understand this, let me take one example. For example, I am writing 4 is less than 5. 4 is less than 5. Is it true? Correct. For example, I wanted to write 5 first and 4 next. What I should do? This less than will become greater than, right? Okay. Same way, if I wanted to write a this side, why I wanted to write a this side? If I transfer x to this side, you will get one advantage. Okay. So what happens is, for example, if you wanted to write, we have something statement like this: a less than b. I wanted to write b first, so it will become b greater than a. Calling a less than b and b greater than a, both are same. Okay. Mathematically, it is same. That is just we are giving a priority a here. Second statement, we are giving a priority to b. Here I would like to prioritize a at this side. So if I write a this side is less than or equal, greater than or equal will become what? Less than or equals to x. Next, I don't want to change this because I want x to be middle, because x I can say here, x I can see here. So therefore I can simply write x less than or equals to b. Okay, x less than or equal to b. So now if I combine these two, here this is also x, this is also x. So what can I write is, okay, can I write this as a less than or equals to x? X is already here, so I need not write x again. Less than or equals to b. So this is the range. This is the range of a comma b. Okay, closed interval a and b. So that is what the meaning of it. Okay, I hope you understood. Okay, so if you want a mathematical way, we can write like this. This is a b. That means to say that a comma b belongs to R. Okay, and x sorry, a less than or equals to x less than or equals to b. Okay, that is how we will write it. So this is called closed interval. Okay, in the same way we will try to understand the open intervals. Okay, right. Okay, the same condition. So here this is a comma b, a open interval and b. So once again, to understand the visual form, I am taking a number line. Okay, let's assume this is a and this is b. Okay, right. Now when you are drawing a open interval, okay, we'll draw like this. These are the brackets. This is how we are drawing it. Now, can I take x value a? No, x value is at this side. X value is this side. Can I take b? No, x value. Okay. Can I take b? No, you cannot take b. You cannot take b. You cannot take a. So a and b are excluded. Okay, but little bit more than a we can take this. Okay, for example, I am taking one point over here. Okay, let's take that point as x. Okay, actually you can take any number of points over here. Now this is actually talking about the entire range of this space. Okay, let us take, can I say x value is x value, can I take a, can I take x value a? No, you cannot take, because it is not included. A is not included, so x should not be a. Okay, now what is the behavior of this value? What is the behavior of this value? Is it this x value, is it less than or greater than? X is greater than a. So can I write x value is greater than a? Can I write equal to a? No, you cannot write. Next, you can look at this point. Can I take x is equal to b? Can I take x is equal to b? No, you cannot take. So x is not equals to b. Okay. So now, what is the meaning of this one? So for example, I am taking this value. This x value, is it left hand to b? This x, is it left hand of b or right to the b? Is it left to the b or right to the b? Left to the b. That means it is always less than. So x value is greater than a, but x value is less than b. Okay, same way. Now these two statements I wanted to combine it. How can we combine it? Okay, I wanted to write a this side, x this side. This greater than will become what? Less than. Now what happens? This is, I don't want to change because x is already there. So x is less than b. How can I combine this? A less than, x is already there. Okay, write b. So this is the range that we can specify for a and b open intervals. Okay, what do you mean by this? X can be greater than a, x can be less than b, but x cannot be a, x cannot be b, and x cannot be a. So this is about this one. This is about closed interval. Okay, right. Next, we can see some more points here. Let's take something like this. Okay, I have an interval like a and b. What is the meaning of this one? Can I take x? X can be what? X can be greater than a or less than a. X can be greater than a. Here x can be b. X can be b, and x value can be less than b. Okay, can I write like this? A, this is greater than, right? X value is greater than a because a is not included. So therefore a less than x, x less than b. So a is less than x. See, I can take x less than or equal. This is two statements. If you combine it, what will you get? You will get x less than or equal to b. So x less than or equals to b. So this is the algebraic form of this interval. So a is less than, x is less than or equal to b. Next, for example, let us take one more. Okay, you can understand the graphical way also. See, it's just like this. We have a here and we have b here. Now we are drawing the like this. Here this b is included. So therefore, x is greater than a but not equal to a. You cannot take x value a. X value can be b, x value can be less than b. Okay, so if you combine together, you will get a is less than, x is less than or equals to b. Next, let's take this like this one, a comma infinite, a comma infinite. So what is the meaning of this one? Let's take visual form. This is a. Can I take a? A is included? Yes, because it is a closed interval a. Now let's take this is plus infinite. So infinite means what? Total this side. So now x value can be equal to, x value can be equal to a, x value can be greater than a. Yes or no? So if you write like this two statements, x is greater than or equals to a, x value can be equal to a or x value can be greater than or equal to a. So how can you write this? X is greater than or equals to a. Okay, right. So generally you will write this in sets form, I mean building form, set builder form in this way. X belongs to R. X what x is can be equal to a or greater than or equals to a. So this is the set builder form of this one. Okay, we can say it is a functional form also. Next, okay. Uh, let me take one more. A comma infinite. A comma infinite, like this. Okay, right. So what do you mean by this? For example, let's try to understand in the visual way. This is A included. So infinite means that side. So is A included? X, is it equal to A? No. X cannot be taken because it is a open interval. X can be what? It can be always greater than A. Greater than A. And it can be greater than A and what do you mean by this? X is greater than or equals to A. Can I write like that? But X should not be A, right? That means X cannot be, see, this X cannot be less than A. X should not be X less than or X should not be A. X should not be less than A. It should not be less than 8. Okay, one second. So here x must be greater than a. X is not equal to a. It should not be a. Now you understood the difference. Okay, let's write it in the set builder form. X belongs to R, comma x is less than a. Okay, x can be any number, but it must not be a, but it can be, sorry, this is less than, greater than a. It's greater than a. Next, a comma infinite. Next, minus infinite comma a. Okay, next one, minus infinite comma a. Okay, so what do you mean by this? Now you can see like this. Let's say a is here. Okay, minus infinity is this side. Now, so a is included. Yes, a must be included. X can be a. Can I say x is greater than a? See, x is greater than a means it is going this side. So we need to take only the space towards this side. So now all the values are it's left of a. Left of a means x values is less than a. So can I write this? X is less than or equals to a. Okay, so that is the space. That is the space. I mean, this is what it will talk about. Okay, x belongs to R. X is less than or equals to a. Okay. Next, minus infinite comma a. Minus infinite comma a. What do you mean by this? Okay, so this is a. You cannot include a, so it's total this side. So how can you say this? X cannot be a. So therefore x must be, see, you are taking x value here. So x must be less than a. X must be less than a. And what you can say? That's all right. So x belongs to R. X belongs to R. And x must be less than a. So that will actually talking about the negative infinity. Okay, it will actually talking about the infinity range from a. Okay, so these are intervals.